Welcome to Math for 4th grade. This is lesson 145, and we are looking at pages 261 and 262. You also have a speed drill for lesson 145, and you'll have 2 minutes on that speed drill. We're going to do a little bit of review, and then I'm going to let you pause it to the speed drill, and we'll get into your page, okay? So first of all, we're going to review our counting back change, okay? So we're going to start with a $5 bill, okay? So you see the $5 bill. I'm going to put the $5 bill on our board, okay? So $5 is what we have to pay with, okay? It's $2. Okay, $2 and 55 cents, okay? 55 cents. Okay, we have to decide if we're going to use dimes or nickels, okay? So if we used a nickel, it would get us where? Okay, here, let's try doing a couple nickels. Okay, so one nickel would bring us up to 260, right? Okay, 260. Okay, well, that's not a 50 or a 75, so we'd need another nickel. And we'd be at 265. Okay? Now we could keep going with nickels, because we needed 2 nickels, in order to use the fewest coins possible, we can trade the nickels out for a dime. That I dropped. Okay? Keep that down there, okay? So if we instead went straight to 265, another dime would take us where, okay? So add 10 cents to 265, okay? Say it with me, 275, okay? We're at 75, which means that we can use what to get to the dollar? A quarter, yay, okay. I love using quarters, okay? So that takes us to $3, okay? So now we have 2 dimes and a quarter, right? We're at $3, okay? We need to get back up to how many, right? $5, okay? So we're at $1, so 3. We add $1 and it's $4. And we add one more dollar to get us to $5. All right, okay? It's hard to see that one, okay? So when we count back, we hand the change to them, and we say, let's see, it's 25, 35, 45. 45 cents makes $3. And then we go 4 and 5 with the 2 $1 bills, okay? So $2.45 is the change from $5 when it cost $2.55. Okay, so this is the change for that. Okay, so that's a good bit of review on the counting back change. All right, and so we're going to look next at this one of these equations, okay? Remember, we have an unknown number in here. S plus 5 equals 9 plus 11. So we do the problem without the side of the problem without the unknown number. Which side is that? 9 plus 11, okay? So 9 plus 11 is what? 20, very good. So we have S plus 5. Make sure that you distinguish an S from a 5 really well so that you don't get them confused, okay? S plus 5 equals 20. Now we need to take 5 off of this side. We have 5, how do we take 5 away? We do the opposite, right? We do S plus 5 minus 5 equals 20, and we have to do the same thing on this side that we did on this side, minus 5. And so then we have S by itself, right? Because 5 minus 5 is 0. So we have S by itself, and 20 minus 5 is 15. Good job, okay? There's our answer. We're going to plug that in. 15 plus 5 equals 9 plus 11. I almost didn't give myself enough room, did I? Okay, 15 plus 5 is 20. 9 plus 11 is also 20, okay? That means that that was the correct answer, okay? I'm gonna let you pause the video and take your 2-minute speed drill, and when you come back, we will look at our page. All right, next we're gonna take a look at this other problem on the board, because we're gonna review multiplying fractions together, but whole numbers and mixed numbers thrown in there, okay? So if we have 12 times 3.5, can we multiply this the way it is, or do we have to change something in order to multiply? We have to change something. They have to be in the same form, right? So we have to turn them both to fractions, okay? This is a mixed number, so we have to make it an improper fraction. This is a whole number. We also make it an improper fraction, but all we do with that one is put it over what number? 1. Okay? Now this one, so 12 over 1, and we're going to have to multiply. Remember, we multiply the denominator, the bottom number, by our whole number, and then we add our numerator, or the top number. So 2 times 3 is 6, plus 1 is 7, and we put it over 2. All right, so I'm going to change this just a little bit so that I don't get confused, okay? So we put 12 over 1, and there's our multiplication sign. Now can we multiply this together, or are they in the same form? Yes, okay. One of the things that we do want to check for is canceling, because then we won't have to reduce later, okay? We don't have to multiply big numbers. So 2 can go into 12, right? How many times? 6 times. 2 can go into 2, how many times? 1 time, all right. So now we've got 1s on the bottom, so we're gonna have a 1 down here. And at the top, we're gonna have 6 times 7, right? You see that? 6 times 7 is 42. Any number over 1 is that number, because 1 can go into 42 how many times? 42 times, okay? Does that make sense? Hopefully that does. If you have questions on that, please let me know. Okay, so 42 is our answer to this one. And we didn't have to reduce anything. We didn't have a fraction that we had to change at the end. We just had to make, and we had 42 over 1, we just made it 42, okay? So, sections 1 and 2 are just multiplying, or section 1 is solving the equations. So I'm gonna have you do all of section 1. Section 2 is more of our multiplying and changing fractions and whole numbers. So I want you to pick 3 of them to do, okay? So you can pick 3, and make sure you do one of them with a whole number, okay? So make sure to pick one of the bottom row, D, E, or F. But then you may pick 2 of the others if you would like that, or if you want to do all the ones with whole numbers, okay? All right, section 3 starts the review. but we are, of course, going to do this, okay? I want to go over some of these things because I've noticed that you guys are struggling with a little bit of this, so we want to just go over it so that you understand it, okay? So first of all, well, the first thing we're going to do is do the metric, okay? So kilometer, which is kilo, hecto, and deca. Then we've got our space here for whatever unit we're in, gram, liter, meter. We have deci, centi, and I am running out of room this time, and milli, okay? So here is how it works. These are all bigger than the middle, right? They're bigger. So these ones, I'm gonna draw this, they're bigger than what's in the middle, okay? These ones, they're smaller, okay? They're itty bitty, okay? Compared to the meter or the liter or the gram. I don't know if we've done gram yet, or liter. We did liter. Okay, so they're smaller. So that means, okay, kilo is the biggest, and it means 1,000. Okay, so there's 1,000 meters in a kilometer. Okay, but kilo means 1,000. Hecto, 100. Hecto, 100. If you can keep those in mind. And that just means 100, right? Okay, so keep that 1,100. Deca. Deca is 10, like decade, okay? Many of you are either close to your decade or have already reached your decade. You've lived 10 years, okay? So if you've made it to your 10th birthday, you've been living for a decade, okay? And so deca is like decade, and it's 10. Okay, 10 whole, okay? This is where it gets tricky because these ones are whole numbers. These ones we can write as either a fraction or a decimal, okay? So we're going to go like this. We're gonna say it's 1/10 or it's 0.1, okay? Either one of those would be a correct answer. 1/10 or 0.1, okay? Centi, did anybody guess what we would put here? If we're making it a fraction, it would be 1/100. Notice that centi goes to hecto. Deca goes to deci. What do you think milli goes to? Milli goes to kilo, okay? So if this one is 1/100th or 0.01, this one is what? 1/1000th or 0.001, okay? So on a test, a quiz, a speed drill, the correct answer for this prefix would be 1/10 or 0.1. Now, if it does say how many decimeters does it take to make a meter, that's when you put 10, because it takes 10 of these to make this. That's why we have 1/10, okay? That can be a little tricky, but I want you guys to remember that. I'm gonna erase these arrows. You get, okay? So deca means 10, deci means 10, but it's 1/10, okay? So it's the fraction. Hecto means 100, centi means 100, but it's 1/10, or 1/100th, I'm sorry, 1/100th. And kilo means 1,000, and milli means 1,000, but this one is 1/1,000, okay? So if it's easier to think of it in the fraction than it is the decimal, do the fraction, okay? If both of them are easy, great. Would be thrilled to hear that, okay? Now, when we change, though, from space to space, so if we put up here K, H, D, D, C, and M. There on C on yours, it says decimeter, which is this one. How many centimeters are in a decimeter is what it says. So how many of these make up this, okay? We've moved how many spaces? Just one, okay? And the number that we use in metric, in this case, is 10, okay? Remember, 10 is our number that we deal with metric, multiples of 10. 10, 100,000, okay? 10, 100,000. This time, we're only moving one space, and so there were 10 centimeters in one decimeter, okay? 10. So C there, go ahead and put 10 for that, okay? I want you guys to be able to get these and to understand them, okay? So however many places you go, you multiply that. So basically you add a 0. So like if you were to go, actually the only other one is hectometer to decameter, okay? So how many decameters are in a hectometer? So you're going to, so we're still going this way, and how many places did we move? Just one. So then how many decameters are in a hectometer? 10. It's the same, okay? It's the same. If you just move one space, now if they had moved from here to here, there's one in the middle, so you don't forget the one in the middle. That's why we leave a space, okay? But if it's D to H, C to D, M to C, H to K, if it's one spot and it's going to the left, it's 10, okay? Does that make sense? All right. How many? All right, so let's do a couple of our measurements, and then I'll give you everything to do, and then or the rest of it I'll let you know what else to do on here, and then let you get to it. So, so if you have, how many pints are in a quart? Pints are in a quart. 2 pints in a quart, right? 2 pints in a quart. How many quarts are in a gallon? Quarts in a gallon. That would be 4, okay? So how would you find out how many pints are in a gallon? You multiply them. 2 times 4 gets you 8, okay? So there's 8 pints in a gallon, okay? How many pecks are in a bushel? How many pecks are in a bushel? 4, okay? 4. So I hope that helps you. If you knew them, great. Review them, make sure you know them good. If you didn't know them, then just go back over them and just get them cemented into your mind. There's one more that's on here that I'm not sure is, well, I know we've done, but I don't know how long ago it was. Does anybody remember how many pounds are in a metric ton? How many pounds are in a metric ton? Okay, first of all, how many pounds are in a ton, a regular ton? It's 2,000, right? Okay, so a metric ton, we add 200 to it. So it's 2,200 or 2200. 2,200 2,200, okay? So that's how many pounds are in a metric ton. All right, so I've helped you with some of these. The rest I believe you can get, and if you can either from what I have on the board or from matter of deduction. Section 4, so do all of section 3. Section 4, or finish section 3 since we started it. Pick one of them to do. Section 5, go ahead and do all of those. Those are pretty simple. And section 6, pick 2 of them. At least one with a fraction and one with a decimal. Okay, that's what I want. So, and then sections 7 and 8 are your homework. And so if you, whether you do that right after you do this or you come back to it at a later time, is up to you and your parents, but do your best. If you have questions, be sure to ask, and we'll see you next time.